Hello everyone, so in this video we are going to discuss about some of the basic system properties and we will see the importance of each of the properties. So to start with, we'll first discuss the system with and without memory. Without memory system is also called memoryless systems. We will discuss about the property of invertibility and inverse systems. Then we will see the causality. We'll also see the notion of stability, time invariance and linearity, and they are quite useful in our subsequent topics. So to start with, we'll discuss about systems with and without memory. As I have already told that without memory system is also called memoryless system. So how to define a memoryless system? So the definition says that a system is said to be memoryless if its output for each value of independent variable here the independent variable can be t for continuous time system and n for the discrete time system. So the independent variable here is time. So output for each of value of independent variable at a given time is dependent only on the input at that same time. So I think the definition looks a bit confusing, so we can have an example to understand what here at the same time means. So we are telling that output for each of the value of independent variable at given time is dependent only on the input at that same time. So let's see and understand this definition by an example. So suppose I have taken a system in which the relationship between input and output is described by yn is equals to 2 of xn minus x square n whole square. So as you can see, it's a relationship model for a discrete time system. So this is a model for a discrete time system. So here, as you can see that the value of yn, so this is your output. So yn is only dependent on a particular timestamp. Suppose I am taking a timestamp of n naught. So y of n naught will be equal to 2x of n naught minus x square n naught whole square. So the output is dependent on the input at that same timestamp of n naught. That's why we are telling it as a memoryless system. It is not dependent on any value of past or future. That's why we are telling it as a memoryless system. So this is a general expression which describes a memoryless system. Can we have any real world application of memoryless system? So yes, their resistors, as we all know, resistors can be an example of a memoryless system. How that we can see here is that we know that the relationship between voltage, current and resistor is given as yt is equals to r into x of t. Here x of t is input and it is said to be current. Here yt is your output and it is called a voltage. So here again, as you can see, for a particular timestamp of t naught, the output y of t naught will be dependent on the input at that same time, x of t naught. That's why it's a memoryless system. Similarly, if we want to see the discrete time counterpart, so we can have an yn is equals to r of xn as a memoryless system. There are some systems which is called as identical systems in which yn is directly dependent on xn. That is also a memoryless system. So this is another example of a memoryless system. So all these are example of memoryless systems. So can we have example for memory with memory systems? So yes, the basic example of with memory system is accumulator. So in accumulator, the expression of yn is equal to summation k is equals to minus infinity n x of k. So here, as you can see that the value of k is varying from minus infinity to n, and y of n naught is dependent on the value which is before n. So it can be some x of, suppose we can take a value of minus 2 plus x of minus 1 till x of n. So before n also the output is dependent on these values. That's why it is called a system with memory. Similarly, a simple example of system with memory can be a delay signal. So if our yn is delayed version of some signal x of n, so this is shifted version of x of n with 1 unit. So this is also a example of system with memory. In continuous time case, these are all both example of discrete time. So accumulator and delay signal can be example of system with memory. Basic example of continuous time case is capacitors. So capacitors is an example of continuous time system with memory, and here the expression can be yt is equals to 1 upon c integration minus infinity to t x of tau d tau. So here also the output is dependent on the value of independent variable which is t at present value also and previous values also. So that's why this is called system with memory. So roughly speaking, the concept of memory in a system correspond to the presence of a mechanism in the system that retains or store information about input values, and that input values are stored at a time which is different from the current time. So here the time are before those at the present value t. So this is the notion of our system with and without memory. So next we will see the system invertibility and inverse system.